Hello and welcome to the Curious STEM video guide for STEM Box experiment number 3, the effect of density and compression on the buoyancy of a Cartesian diver. I'm Sidhya and I'm going to guide you through your experiment today. Today's experiment uses a Cartesian diver to help you learn a lesson about buoyancy and pressure. Cartesian divers are small objects used in science experiments that are meant to show the effect of pressure and density on whether objects sink or float. First, let's hear from our CurioSTEM executive members, Shivani and Vaishnavi, who will give you an introduction to the experiment as well as some background information.
Hello, young scientists. Welcome to one of our lessons for the effect of density and compression on buoyancy. First, we will be discussing what density is. Let's think about what happens when oil is put into water. Look at the picture to the right. The oil rises and floats on top of the water. Why is this? Well, it's all because of density. Density is the amount or mass of a substance that is contained within a given space or volume. There are a few components that contribute to the overall density of an object or substance, including mass and volume.
Mathematically, you can define density as mass divided by volume. Mass is the amount of matter or substance in an object. Think about mass as a ball of clay. When you add more clay or matter, the mass of the ball of clay increases, and when you take out some of the clay, the mass of the ball decreases. Volume is the amount of space an object takes up. So for example, the amount of water inside your water bottle takes up a certain amount of space. So I have a trick question for you. Which is heavier, 1 gram of feathers or 1 gram of gold? The answer is that 1 gram of gold is just as heavy as 1 gram of feathers. They both weigh 1 gram. So here's another question. If you had 2 boxes, both of the same size, and you filled one with gold and one with feathers, which box would be the heaviest? Now the answer to that would be the box filled with the gold. Because feathers aren't as dense as the gold, the same volume of feathers would be much lighter. There are some factors that affect the density of an object. Compression is the action of squeezing something tightly enough to decrease the volume. So take, for example, a stress ball. When you squeeze it very tightly, it shrinks in size, so the volume decreases. Therefore, density increases as the compression increases. Another example is scuba diver suits. Life jackets contain foams that trap air in pockets when submerged. The air pockets give them a lower density, which allows them to float. But when a scuba diver submerges deep into the water, the air bubbles in their wetsuit become compressed. This causes the diver to become denser and go into the water.
Let's take a look at the principles of sinking and floating next. Now that you know about density, what do you think happens when a highly dense object is put into a fluid? Will it sink or float? What about an object with lower density? Keep these questions in mind as we move forward. We will come back to them. We have seen many objects float on water, such as ice, wood, and empty bottles because of their lower density. Other objects tend to sink, like rocks and pebbles, because they have higher density than water. Let's answer the questions now. What happens when an object with higher density is put into a fluid? It will sink. What happens when an object with lower density is put into a fluid? It will float.
So now we are going to do a couple of practice questions. See if you can figure out the answers before I tell you what they are. So here we have a coin. Do you guys know whether it will sink or float? Well, if you have ever put a coin into a fountain, the coin will sink to the bottom of the well. This is because the coin has a greater density than the water. On to the next question. So now we have balloons. Will it sink like the coin in the water, or will it float? Well, it'll actually float because it is less dense than the water because it's filled with air, which has a lower density. Okay, final question. How about submarines? Well, let's take a look at some pictures. So here we have a picture of a submarine floating in water. But this next picture shows that the submarine is sinking. So it can sink and float. But why? What mechanisms allow for submarines to sink and float? Let's find out.
We are now going to discuss the topic of buoyancy. The definition of buoyancy is that it's the power of a liquid to keep something afloat, or in other words, the ability to float in water or some other substance. So earlier we saw that submarines have the capability to sink and float. A submarine is only able to submerge into the water while it takes in water through tanks until its body is capable of sinking. The inflow of water allows the submarine to gain mass, which means that its density increases. Do you remember what we learned earlier about density? The higher the density, the more likely it is for an object to sink into a fluid that is less dense. Through this process, pressure is directed upwards, causing the submarine to descend into the waters. Water directed inwards allows an object to sink. Now, when the pressure from the buildup of the water is released and the water itself is released, the submarine is able to push itself back to the surface of the water and float as it loses density. Another brief example is when you're out swimming. Have you ever thought about why we are able to stay on top of the water when we have an inflated float? The float is full of air, and the density of air is significantly less than that of water, and that is why the float is able to stay at the surface of water, even when our weight adds pressure to the float.
Now we are going to look at the Cartesian diver, which is what you are going to be making during your experiment. So here are just a couple of photos that show what the Cartesian diver will look like, which you can find with just a simple Google search. So while you are creating your diver, make sure to have a lot of fun and answer the questions so that you can understand density and buoyancy better. Happy experimenting!
Okay, now that you understand how density and pressure affects whether an object sinks or floats, let's begin the experiment. Open your STEM box and take out the worksheet, which should be at the top of your box. The worksheet looks like this, and it's titled, The Effects of Density and Compression on the Buoyancy of a Cartesian Diver. Take a couple of minutes to look through the worksheet and read the procedure, just to get an idea of what the experiment's about. Next, take out the plastic bag in your STEM box. This bag contains all of your materials, and you need to make sure you have all the materials that are listed on your worksheet. Make sure not to disturb any of the items because you'll need them for your experiment. The first thing you need to do is to get a pencil or a pen and begin filling out the chart that's on the second page of the worksheet. This chart is the experimental design chart, and it explains the independent variable, dependent variable, and the constants of the experiment. Variables are things that change in the experiment, and independent variables are changed on purpose, while dependent variables are changed as a result of the experiment. We are only going to be filling out part 1 of the chart right now, so keep part 2 blank for now. So, independent variables are changed by the experimenter in order to test the effect of a specific factor on the outcome of the experiment. Go ahead and reread the title at the top of your worksheet, which says, The Effect of Density and Compression on the Buoyancy of a Cartesian Diver. And you'll understand, after reading the procedure, that the independent variable of this experiment for part 1 is density. Specifically, the density of a Cartesian diver. There are 3 different levels of the independent variable that we will be using in this experiment. Number 1, a Cartesian diver with no washers attached. Number 2, a Cartesian diver with 1 washer attached. And number 3, a Cartesian diver with 3 washers attached. Washers are these circular metal objects that are used when assembling nuts and bolts, and they are the perfect way to add more density to a Cartesian diver. So the Cartesian diver with no washers represents the least dense. The Cartesian diver with 1 washer represents a slightly more dense object, and the Cartesian diver with 3 washers is the most dense. Next, let's look at the dependent variable. If the independent variable is the thing that is changed in order to get a certain effect or result from an experiment, then the dependent variable is identified as that certain effect or result, because it depends on the independent variable. So, going back to the experiment title, The Effect of Density and Compression on the Buoyancy of a Cartesian Diver, it is clear that the dependent variable in this experiment is buoyancy. However, we do need to include a little more detail. In this case, buoyancy is represented by whether the diver sinks or floats and its overall behavior in the water. Lastly, let's consider constants. Constants stay the same or stay constant throughout the entire experiment. We keep these things the same so they don't mess up our experiment's results, and we can truly make sure that the independent variable is making the changes in the experiment. By keeping some things constant, we are preventing any outside interference in the experiment's results. Some examples of constants in part 1 of this experiment are the amount of water, the materials used to make the diver, and the pressure. Okay, now it's time to do part 1 of the experiment. The materials that you'll need for part 1 are the 3 Cartesian divers and the cup. Take a moment to go fill up the cup with water from your own kitchen. Make sure you aren't opening the sealed water bottle that's also in the box, because you'll be using that in part 2 of the experiment. Okay, once your cup is filled up with water, open up the small plastic bag that contains the Cartesian divers. Take out the red colored diver with no washers attached and drop it into the cup of water. What happens? Go to page 4 of your worksheet and write down your observations in the data table labeled Part 1, in the row labeled Checkpoint 1. Then, after you write your observations, which should be explaining how the diver floated to the top of the water, write the reasoning as to why this may have happened in the second column in the table. Think back to what you learned about density so far. Now, take the red diver out of the water. Next, take the green diver with one washer attached from the bag and drop it into the cup of water. What happens now? Go to page 4 of your worksheet and write down your observations in the data table labeled Part 1, in the row labeled Checkpoint 2. Then, after you write your observations, which should be explaining how the diver floated in a vertical position at the top of the water with the washers facing downwards, write the reasoning as to why this may have happened in the second column in the table. Think about how the density of the diver was different from the first, and how this may have affected the diver's buoyancy in the water. Now take the green diver out of the water. Next, take the pink or blue diver with 3 washers attached out of the bag and drop it into the cup of water. What happens now? Go to page 4 of your worksheet and write down your observations in the data table labeled Part 1 in the row labeled Checkpoint 3. Then, after you write your observations, which should be explaining how the diver immediately sunk to the bottom of the water, write the reasoning as to why this may have happened in the second column in the table. Think about how the density of this diver may have caused it to act differently than the other divers. You should have filled out the first 3 rows of your table by now, and your reasonings and observations should be similar to this. Of course, your wordings and explanations may be different from mine, but the overall meaning should be similar. Now it's time for part 2 of the experiment. While part 1 tested how density affects buoyancy, part 2 will deal with how pressure affects buoyancy. Go to page 3 of your worksheet and read over the procedure for part 2, and try to understand the purpose of the experiment. Go back to page 2 of your worksheet, because we need to fill out the experimental design for part 2. Use your knowledge of the definitions of independent and dependent variables and constants in order to fill out this chart. Okay, since we are seeing if pressure affects buoyancy, then the independent variable, which is the factor that is changed by the experimenter, is pressure. Specifically, it is whether the bottle is squeezed or released. And the dependent variable is buoyancy, or specifically whether the diver sinks or floats. The constants for this experiment are the things that stay the same. Actually, in part 2 of the experiment, density is a constant, because we're only using the diver with 3 washers attached. We're keeping density as a constant because in this part of the experiment, we're testing pressure as the independent variable, and we don't want to change too many things because it may mess up our results and provide us with inaccurate conclusions. Other constants are the amount of water and the temperature of water. Let's do the experiment now. Take the water bottle from your stem box and open it, and drop the pink or blue diver that has 3 washers attached into the water bottle. Then, put the cap back on your bottle very tightly. What is happening to the diver? Is it sinking or floating? Write down your observations in the chart on page 4. Your answer should look something like this. Now squeeze the bottle and see what happens to the diver. You should see that the diver is sinking to the bottom whenever the bottle is squeezed. Next, release the bottle and see the diver float back to the top. Record your observations in the part 2 chart on page 3. Now let's try to form some conclusions based on our observations. Go to page 5 of your worksheet and pause the video here and try to fill out the conclusions section at the top of your page. Okay, your conclusions should look something like this. When you squeezed the bottle or applied pressure, the water went inside of the diver, making it more dense. Because it is more dense, it became less buoyant. And the less buoyant the diver is, the more it sinks. This is why the diver sunk to the bottom whenever you squeezed the bottle. And the increase in density is also the explanation for why the more dense diver in part 1 sunk to the bottom of the cup. But how does this apply to the real world? You can follow along with the explanation on the last page of your worksheet. Through this project, you have successfully investigated how to design a Cartesian diver experiment in order to simulate the effects of buoyancy on an object's ability to sink or float. Did you know that submarines are almost real-life versions of this experiment? A submarine is only able to submerge into the water while it takes in water through tanks until its body is capable of sinking. Taking in water allows the submarine to gain mass, and pressure is directed upwards, causing the submarine to descend into the waters. Water directed inwards allows an object to sink. Imagine this. When you're swimming, you are prone to drown if you swallow a lot of water. This is because the water is adding a lot of mass to your body, and this pushes you downwards. But if this same water is released, you will start to float. Those are only 2 out of many real-life examples of this concept. Can you think of any more? Thank you so much for participating in this Curious STEM science experiment. We are so proud of you for completing this experiment and learning more about the scientific world. Curious STEM encourages young scientists like you to keep being curious. Research and find out more real-world applications of this concept if you like. Please contact us with any questions at curiousstem@gmail.com. You can even send pictures or a scan of your completed worksheet for this experiment, and we will send you a surprise to congratulate you. More information about our organization and programs can be found at our website, curiousstem.org. Thank you for watching.